Hello everyone. Today I am here to discuss the very important concept from the gears, the path of contact and arc of contact. So let's introduce myself. My name is Dr. Irshad Ahmad Khan, Associate Professor in Department of Mechanical Engineering, Sagar Institute of Research and Technology, Bhopal. So let's understand this concept, path of contact. So simply we can say the path of contact is when the two mating gear come in contact. So this engagement is begin when the addendum circle of the wheel it meet the path of this path of travel, or we can say the line of action. This line EF, and this EF is also called the common tangent to two mating wheel. Okay, so engagement is begin from this point C. This is the addendum circle of the wheel. Okay, and this engagement travel in this path C to P and P to D, and this disengagement of two gear is happen at point of D when the addendum circle of this pinion is small one. It is intersect this the line of action of mating gear. So here we are assuming that big one, this two, it is wheel, and this is small one is the called pinion. And so to more understand about path of contact and get the derivation of path of contact, we have to be assume some parameters like smaller pitch circle radius of pinion. This is pinion and pitch circle, this one, and this middle circle is called pitch circle. So pitch circle radius of pinion is small one is called the pitch circle radius of the wheel, and RA is the addendum circle of the pinion, and is that capital RA is the addendum circle of the wheel. And this diagram is drawn to make this calculation easy. We have just removed all the wheels, like or circles of the two mating gears, and the both this addendum circle, base circle, base circle, and addendum circle of both pinion and gear. So this is the made simple our calculation, and we will use some trigonometry, and we get the path of contact. So let's understand of that. So next slide. So its path of contact is basically, you can see the engagement begin from C and disengage at D. So CD is called path of contact, and it's also have two parts, that CP plus PD, and part CP is called path of approach and PD is called path of recess. So we have to calculate this one. So CP we can also, here you can see in this diagram basically, so CP we can also write CP is F, you can see FC minus of PF. Okay, and PD, this P and D we can write this DE minus of DE and minus of this PE. So you can simply understand, you can get this is geometrically, you can see the trigonometry, you can apply this right angle triangle. So simply because we know that this you can see that this is this is the pitch circle radius for the V, and we already assume this is R. So if we once we know that this pitch circle radius, okay, so we can write this part is the R cos phi, and this part become P to F. This P to F, this become R sine. Similarly, this concept we can also apply here in that pinion part. Okay, so we have applied. So simply we can write this formula, and just find the value of CP. Here the CP is, if you can see, this is a perpendicular, and this from B to C, this is called RA, that is called hypotenuse. So we can write under root of R a square minus this one R square cos square phi minus of this PF is R sin phi. Similarly, we are apply this concept for the pinion part. So we can get R small r a square minus R square cos square phi, and this minus this R sin phi. The rewrite, and this equation become this like this. So once we need to calculate the path of contact, we can use this relation. If we know the all the parameter used or present in this equation, with by the help of this we can calculate the path of contact. Hope till you are got that concept. So let's discuss arc of contact. So arc of contact, this concept is basically, you can see the arc of contact distance traveled by a point on either of this circle of two mating gear. So this is called pitch circle. You can see we have made one circle. This is called pitch circle. So this P dash, P and P double dash, this is called the arc of contact. So similar to the path of contact is also divided to part, P dash to P and P to double dash. Okay. So this P to P dash to P, this is called arc of approach, and P to P double dash, it is called arc of recess. So to solve this, to find the arc of contact, so let's assume the less time to traverse the arc of approach is dA, then arc of approach P dash to P is equal to tangential velocity of P dash into time of approach. This simple concept. Okay, so tangential velocity of V can be written as this angular velocity of this wheel, that is omega A, and the distance from this P. So this is called this circle radius, and that is R. So once we multiply with this and into time, we can rewrite R into cos phi 1 upon cos phi dA. So this part become the tangential velocity of H, you can see, because this RA cos this radius, and this angular velocity is same for this also. So it's become tangential velocity of H. And tangential velocity of H into dA, this is called arc HK. You can see this distance travel by this. So this become arc HK. Hope this is simple concept you understood. So arc HK, we can write the arc FK minus of arc FH. Okay. And also we can write that arc FK is equal to FP minus FC. This is happen because arc FK is equal to path FP. As a point P is as a point, you can see P is on generator, P is on generator FP. Okay, that's why. So this become, so we can write what we have written here. You can see. So this part, this become FP minus FC, and this FP minus FP in diagram, you can say that becomes CP. And if you remember what is CP, CP is path of contact. Okay, hope you are getting this thing. Similarly, we can apply this concept to calculate the arc of races, means P to P double dash part. This from this to this same concept, the tangential velocity of P into time of races in omega A into R dr. Then we can rewrite this R, this to reach this R cos phi, and this, and here the R cos phi becomes the tangential velocity of K. Okay, this radius is same for each point HKL. So we can reach here like this. So now we can rewrite the tangential velocity of k into dr is equal to rkl upon cos. So here we can write also that kl is equal to r fl minus r of r fk. So similar some concept what we have applied here. So we can get this arc FL equal to FD minus this become FP cos 5 and this become PD. So we add both things. So become arc of contact is equal to CP cos 5 plus PD upon cos 5. This becomes CP plus PD is equal to CD upon cos 5. Path of contact upon cos 5. So this is relation for the arc of contact, and we can also calculate the number of teeth in contact by using this relation, the arc of contact upon circular pitch. So this is this relation. If some time this come the question, calculate the number of teeth in contact, we can use this relation. So thank you so much for attending this lecture.